All right, everybody, section 2.12, logarithmic manipulation. We have some new properties of logs we're going to go over in a second. And we have one from a previous lesson I just want to remind you guys of, that if the base of the log is the same as what's inside the log, it's automatically going to equal 1. All right, so our new properties say this, that if we're multiplying inside of a log, that is the same thing as adding two logs separately, or vice versa. If you're adding two logs, you can actually multiply what's inside of the log. Conversely, if we're dividing inside of a log, that's going to lead to subtracting two logs separately, or vice versa. If you're subtracting two logs, then you're dividing inside the log. And then lastly, if there's an exponent inside of the log, right? So if you've got a to the c right here, with logs, you can actually take that exponent and move it in front of the log. Or vice versa, if it's in front, you can move it up into the exponent. All right, so I've got three problems here that we're going to expand out. And so what that means is we're going to start with something like one of these three that's to the left of the equals. And we're going to write it as whatever's on the right side of the equal sign. So first question, we've got the natural log of 4 times x to the second. And so because we're multiplying inside the log, we're going to actually end up with two natural logs. So we're going to have the natural log of 4. We're going to have the natural log of x squared. And that multiplication turns into addition when we make it two separate logs here. One additional thing we could do, we have an exponent now inside of our log. And so we could bring that to the front of that term. And we could write it like this. Right there. And so that would be an expanded form of the original question. All right, next one. So here we've got multiplication in the numerator, and there's also division. So we have two different operations here. So we're going to split this up into 3 logs, all with a base of 3. The two that were in the numerator, we're going to put those two first. So we're going to have a right here, and we're going to have the cube root of b right here. Now, because those were being multiplied in the numerator, we're going to put a plus in between them. The c will be the last log, and because it was in the denominator, whenever we're dividing by something, it turns into subtraction, like that. All right, so if you're multiplying in the numerator, you're going to have a plus in between the logs. If something's in the denominator, it's going to have a minus in front of it. All right, now this is most of what we had to do on this one. However, we could rewrite a cube root as an exponent of 1/3. All right, a cube root is the same thing as an exponent of 1/3, and then we could take that 1/3 and we can move it in front of the log. So let me just erase that so I don't have to write the whole thing again, but we're going to put a plus here, and then we're going to bring the 1/3 in front of the log. All right, so that's how it'd be written on a multiple choice question right there. All right, that's the answer to number 2. Now the third question. So again, we've got 3 things inside of the log, and so we're going to end up with 3 logs here. So we're going to have the log of x, we're going to have the log of y, and we're going to have the log of z. Now, when there's multiple things, it can get a little bit confusing because there's multiplication happening in the denominator. But if we just think of it like this, anything that's in the numerator is going to be a positive. So I'm going to have a positive in front of the first term, which we don't have to write. But everything else is in the denominator, and so we're going to make both of those a minus here. Another way to think about this is some people will say we're subtracting all of this, and this is a plus because we were multiplying. And then you distribute. So once you distribute, you're right back here. All right, so again, if something's in the denominator, I just go ahead and make it negative. And if it's in the numerator, I'm going to have that log being positive, but we don't need to put the first term as being positive. All right, so that's it for that one. And then the last one, we're going to condense this. And so we have 4 logs here, but we're going to condense this down to one single log at the end. Now, the first thing to do is if there's ever a number in front or something in front of the log, we want to move it up into the exponent. So the first thing to do is get rid of that 2 and just move it up here. And get rid of the 4. Don't move the negative, just the 4. And it's right there. Now what we can do, because they all have the same number in front except for the positive versus negative, is we can make this all one log. There is subtraction, so we're going to have a fraction. In the top, we're going to put anything that's positive. So our first term is positive, so x squared goes up here. Y also goes in the top. And then in the bottom, we're going to have a z to the fourth, because there's a minus in front of that term. And we're going to have a, because there's a minus in front of its log. All right? So again, you're either going from, if you're expanding, you're going from having one log to however many variables there are, you're going to have that many logs. Or vice versa, you're going from having multiple logs down to a single log. That's all we're looking to do here. All right? That's it for this one, guys. Stay flawless.